Hi, I am back in my workshop ready to tell you about the next rocket I am launching. Here is everything that you'll need to know. On the previous flight of my rocket, you may remember that I flew an Arduino-based flight computer called Neuron, and Neuron failed to detect launch on takeoff, and initially I blamed this on messy wiring and just all that mess and short-circuiting somewhere, and just didn't connect to the sensor properly and didn't detect launch. However, about 6 months later, after that, I was looking through the old code and I found this line where, if you know anything about code, you'll see that these two equal symbols, that means if this happens, it will check to see if that is equal to that. Instead of what was supposed to happen, where if this happens, it sets that number to be equal to that value. And pretty much what that means is when it detected that it was taking off, Neuron checked to see if it was taking off. It didn't actually set itself to be in flight, and that's what pretty much it just didn't record the data after that point, which kind of really sucks. And in a minute, I'll tell you about the improvements I've made to fix that problem. But first, I just want to talk about how in my last video, I said my next rocket will be EON MK4 and not my next level 2 rocket, like I said in my last rocket video, which is called Selene, as you can see on screen now. And the reason for this is because I realized that I wanted to fly Neuron on Selene as the only flight computer on board, and in order to do that, it needs to work, right? So before I fly Selene and risk the big expensive rocket with the $1,000 engine in it, I wanted to fly Neuron first on a much cheaper rocket to make sure it actually works, and EON is about $100 compared to 1,000 of Selene. So that's obviously the much better choice, right? So I started making EON MK3, and that was going to fly Neuron as the old design but with some improvements, and it still had the GoPro on board, and it didn't sit right with me. Like, something felt wrong about it, and basically what I ended up doing is just redesigning the entire upper part of the rocket, and that ended up I just called it EON MK4 because it's different enough now. So here's what makes MK4 different to Mk2. Here is the avionics bay for EON Mk2, and as you can see, there's a big window on the side for the camera to look out. It's pretty, it's like a hand size. Nose cone can unscrew itself and the flight computer sits in there. That design's pretty simple and it works pretty well for what it needed to do. But with the improvements I wanted to make with Neuron, I needed more room in the avionics bay. So instead, I upsized the avionics bay to this, which may look roughly the same, but actually this entire space can be used for the avionics bay, whereas for this one, it's just this space that can be used for the avionics bay. And this is also completely hollow all the way through, where one of the biggest improvements I wanted to change was the GoPro on board was really heavy. It's like 300 grams or something, and I wanted to save that weight, obviously, because weight means everything on these rockets. So instead, I swapped it out for this, which you may not know what it is, but you see these holes on the side? Those are mounting points for this, and this is a little analog camera set up, and there's 2 of them there, and they will sit on the side of the airframe like that, looking up and down the rocket. Now, not only are these cameras way lighter, each one weighing about 5 grams each compared to the GoPro, which is hundreds of grams, but they also can be powered on and controlled remotely using a digital pin on a computer. And Neuron has plenty of these digital pins spare, so that's exactly what's going to be doing pretty much. So using the new upgrades that I will show in a second for Neuron, I can send a signal to these cameras to start recording remotely, which makes it just a more streamlined process. And they, while they are lower resolution, they still will do the job pretty well, and we get 2 new angles looking down as well. Now let's talk about Neuron itself. This is the new Neuron setup, which just looks, comparing that to this, which is the first Neuron version, this just looks incredible. Also see that the main flight computer here is a Raspberry Pi instead of an Arduino, but it still is using Arduino code for it. Another improvement is I've also got a micro SD instead of the full-size SD from first Neuron, which makes things smaller. On the inside there's a pretty beefy voltage regulator which will drop the high voltage battery that is now in the avionics bay down to the right voltage to be used in here. And it's a bit messy, but on the back this is the LoRa antenna, and this antenna is quite long range. I did a test a few days ago and it got to a few hundred meters away from each other and they could still talk to each other. And this LoRa antenna will be communicating back to my laptop, which has a second LoRa antenna connected to it, and they can talk and send telemetry and commands and whatever back and forth. This also means I can arm Neuron remotely, which just makes things easier. That is Neuron for EON MK4, and I do plan to do an EON MK5 as well, which will be just a similar test, but just to actually use Neuron to deploy the parachutes. That's going to be quite a scary moment. But yeah, for now it's going to stay as that 3D printed base plate with all the parts in it and then wired together behind it. But for EON MK5 it will be a custom circuit board, which will be the exact same functionality, just on a circuit board instead, just to neaten everything up even more. This is the internal structural support for the avionics bay, and this is the cover for it. And these two parts go together like that. You see there's two prongs stood out, and then a cap goes on there and holds it closed, and the nose cone screws on. And this is a pretty common setup for rocketry, and you can pretty much just zip tie your electronics onto the rail like that and it will hold it perfectly fine. It'll be about there and the battery will sit under here. It's I'm planning to use one of two different batteries. The current one is 23 volt, but I might use a 14 volt battery instead. Here's the body tube for EON MK4, and the top looks roughly the same, the bottom looks roughly the same. These white set of fins is actually a scientific experiment for Koyos Aerospace, which is a startup group that I'm in, where we need to test this system. Essentially what this system does is it's basically just four normal fins, well actually 3 normal fins, but one of these fins has a little tab here. And this tab is connected to a motor which can be controlled by Neuron. And pretty much what's going to be happening is there will be a magnetometer which is measuring the compass direction to north, and as the rocket goes up it will spin slightly just from imperfections, and this tab will go the opposite way to that spin and counteract it, which will essentially stop the rocket from spinning. This stability option has two main advantages to what it does. The number one thing is it stops the rocket from spinning, which means the antennas aren't constantly moving and they can keep a constant communication between the ground and the antennas. And it's not much of an improvement, but it is definitely noticeable. Another improvement is the onboard cameras. They won't be seeing just a blur of the terrain swinging past as the rocket spins at hundreds of times per second even. So this thing will get smooth video for the rocket, and the rocket that this is eventually going to be flying on is the Koyos Aerospace's space rocket, which we are working on, and it's going to take maybe a few more years until we can launch it. You may be wondering why make a second set of fins instead of just put them onto the main fins, and I'm going to be completely honest here. I had already made these, and they work perfectly fine, and there's no point just to remake an entire set of fins for a single control tab. So this was much cheaper to do than making all of this again. The engine inside of EON will be the same as it has for the last 2 flights, as I know it works and I know its ability. So I'm not going to be taking any risks. I just want the system to prove itself and to work. And other than that, that is all of EON MK4. If you have any other questions or any comments to make about EON, then just leave them down in the comment section. I love reading comments and I respond to almost all of them. And if you've watched up to this point, thank you for watching. Please subscribe. And yeah, I'll see you in the next video. Bye.